Hi, in this short video, I will explain some common mistake related to the antiderivative of some function giving rise to a logarithmic function. So let me start first by recalling the derivative of ln function. So if we have ln of u of x derivative, this is equal to u prime of x over u of x. Okay, so u prime here. And as example, I will give simple example for that. We have, for example, ln of 4x squared plus 1 derivative. This is equal to, so the u, this is u of x. So do u in the denominator, which is 4x squared plus 1. And in the numerator, the derivative of 4x squared plus 1, which is 8x. Okay. So from this, we concluded also the antiderivative of u prime of x over u of x dx. This is equal, in fact, of ln of absolute value of u of x plus c. As an example, we can compute the antiderivative of, let's say, 2x squared minus 1. And since I have here 2x squared minus 1 in the denominator, so the derivative of this, it's 4x. I will make things easy to prepare the antiderivative there. So this is equal to ln of the denominator, which is here, with an absolute value. Since I don't know if the denominator is positive or no, so I have to put this absolute value plus constant c, because the integral is indefinite. And another example, we can think about this antiderivative x over x squared plus 1 dx. And here the antiderivative is not completely ready to be computed. It needs some other correction. So I will put here, since the derivative of x squared plus 1 is 2x, but in the denominator I have x only, so I will multiply by 2 and divide by 2. So it means multiply by half. And I will put the half outside of the integral since it is cancelled. Okay, so this is, I didn't change the expression, that's just the form of the expression is changed here. And now we are ready to compute the antiderivative, which gives ln. So it's 1 over 2, which is outside of the integral, and inside it is ln of absolute value, x squared plus 1. And here, if you observe, plus c, of course, but x squared plus 1 is all the time positive, so no need for the absolute value in this writing. Now, I will go through the common mistake that I saw in many papers. So the mistake here is the following. Some can write like that. 1 over x squared plus 1 dx is equal to simply ln x squared plus 1 plus c. And this is, of course, wrong. It's totally wrong. Okay? Because we don't have here, this is the u of x, and here we are missing the u prime of x. So there is no u prime which must be 2x. So we cannot write this is wrong. Of course, we cannot write this antiderivative like that. Of course, there are other formula with tan minus 1 or arctan for this, but my focus today is for this mistake, and I will go through the mistake that I saw somewhere. So like, for example, saying 1 over x squared dx, this is ln of x squared plus c. This is wrong, of course, again. And why this is wrong? Because we know the formula. In fact, the correct setting is like that. In fact, we have an integral of 1 over xn, x to the n, tx, will give rise to two possibilities, depending on this number n here. So if n is equal to 1, so it's like antiderivative of 1 over x, and this will give ln of absolute value of x plus c. But if n is not equal to 1, and here comes the trick, so this is exactly x to the power minus n dx, and I can apply the formula of the power. So it's x minus n plus 1 divided by the new exponent, which is 1 minus 1 plus n. And you see here that in the denominator, it makes sense because this is not equal to 0, because n is not equal to 1. If you write this with the n equal to 1, this is wrong. Of course, you have a division by 0. So I wanted to emphasize on this common mistake, just for your background, to not do this mistake again. And in general, roughly speaking, if we think about when we get the logarithm, it's ln, roughly speaking, it's not exact here. We should have something like degree of the denominator, somehow in the numerator degree minus 1. This in general will give something like, for the antiderivative, something which is related to the ln. This is not exact, of course, but the main idea is that when we have degree in the denominator, somehow in the numerator degree minus 1, you need to make some corrections, of course. But the idea is that this will give some, in some parts, the logarithmic function as antiderivative. Thank you so much.